In this video, we're going to be looking at metallic bonding, and we're going to look at some of the properties that arise because of metallic bonding. So I've listed some of the common properties of metals. These are the ones you're going to have to explain in a bit more detail at this level. The first property we're going to be looking at is this word malleable, and what this means is that metals can be bent or hammered into shape. So if I was to say use an iron nail as an example, if I magnified it millions of times up to the atomic level, I would see the iron atoms neatly arranged like this. Because it's all made from iron atoms, they're all the same size. If you hit this really hard with a hammer, then the layers of iron can shuffle past each other. So each time I hit it with a hammer, they will keep on shuffling. So at this stage, we can say the metal is bending, and this is referred to as malleable. Now you could also have alloys. An alloy could be a mixture of a metal and a non-metal, or it could be a mixture of metals. What you have in this case is atoms that are of a different size. So you've got the red circles here and the smaller grey circles. If you try to now hit this with a hammer, it becomes difficult to get these layers to slide past each other because all the atoms are of a different size, and the atoms will try to resist any shuffling, and this makes alloys much harder and stronger than pure metals. Our second property is electrical conductivity. Now we all know that metals can conduct electricity because pretty much all of our household appliances are powered by electricity, and the cable that is connected to the mains must be a good conductor, and all metals are good conductors of electricity. I want you to remember one simple fact about metals, and this is that they tend to form positively charged ions. So they lose the electrons in the outer shell quite easily. So I'm going to put a positive charge on every single metal atom over here. So I've now labeled all the metal atoms as positively charged, and these positively charged metal atoms are often referred to as cations. And a cation is just a positively charged particle. You may have also noticed these blue circles over here, and these are called free electrons. So these are the electrons I was talking about earlier, which the metals lose quite easily. And I'm just going to label that as well, free electrons. Now they're called free because they can move throughout the whole structure, okay, and this is what allows metals to conduct electricity. So this charge is carried across when this is connected to a power source. Our third property is that metals have high melting and high boiling points, and just to make this a bit easier to explain, I'm going to look at one free electron and one cation. Now we obviously said that cations are positive and free electrons are negative. They're both oppositely charged, so they're going to attract. So just think of a magnet. If you have a magnet and you put north and north together, because they're the same, they're going to repel. But if you put north and south, they're going to attract. So this is given a special phrase, electrostatic attraction. It just simply means attraction between oppositely charged ions. So let's go back to our metallic bonding structure. Now what you have is loads of free electrons and loads of positive cations. Now what's going to happen is that they're all going to attract, and it keeps this structure very compact like a glue, and separating the cations and the free electrons requires a lot of energy. Just to add on to that, metals also form giant metallic structures as shown over here, and to melt this metal you have to separate every single one of these free electrons and the cations, and that requires a tremendous amount of energy, which is the reason why metals have high melting and boiling points. Just to summarize everything, the first thing we looked at was this word malleable, which means that metals can be bent or hammered into shape. The second thing we looked at was how metals can conduct electricity because they have free electrons. The third thing we looked at was the strong electrostatic attraction between the positive metal cations and the negative free electrons. and how this explains why metals have high melting and high boiling points. Finally, we looked at how metals form giant metallic structures, which once again contributes to the high melting and high boiling points of metals. That is pretty much the end of the video. I am going to leave a link to some exam questions in the description box so you can apply your knowledge. Other than that, thank you very much for listening and have a nice day.